Hi, let's discuss another question from Quant 200 series. It says all natural numbers from 1 to 100 are written sequentially in a single row, forming a large number n with 192 digits. So basically, n is equal to 1, 2, 3, 4, 5, so on, 99, 100. Now, how many single digit numbers are there? 9 single digit numbers, 1 to 9. How many 2 digit numbers are there? 92 digit numbers, 10 to 99. And there is one 3 digit number. This gives us 192. That's why it says it's a 192 digit long number. A single partition is placed between any two consecutive digits of n, splitting into two parts. These two parts are then added to form a new number n1. This process is repeated. n1 is split into two parts at any position and their sum forms n2. The same operation continues, generating n3, n4 and so on. A single digit number nm is obtained. What is the value of nm? So surely we are not going to check all these 192 digits, right? All these long number, the same operation. But we can try by taking some example. Like if I'm taking only a 2 digit number, 1, 2. If I put a partition here. So 1 plus 2, what we are getting? 1 plus 2 is equal to 3. Then if I'm putting a partition in a 3 digit number, this will be 1 and 23. Sum will be 1 plus 23, which is equal to 24. Now let's again put a partition. Then this will be 2 plus 4, which is equal to 6. Now we can also put the partition instead of between 1 and 2, I can put it between 2 and 3. Then we are getting 12 plus 3, which is equal to 15. And again, if we put the partition between 1 and 5, then we get 1 plus 5 is equal to 6. Then again, let's take a 4 digit number, 1, 2, 3, 4. If I put a partition between 2 and 3, then 12 plus 34, this is equal to 46. Then if I put a partition between 4 and 6, 4 plus 6 is 10. Then again put a partition between 1 and 0, we are getting 1 plus 0 is equal to 1. Now what if I put the partition instead of between 2 and 3, I put a partition between 1 and 2. Then sum of these two numbers, this will be 1 plus 234, which is equal to 235. Now let's put the partition here. Then we are getting 28. Then again put the partition here. 2 plus 8 will become 10. And again put a partition here. The sum will be 1. So it does not matter where we start with the partition and how do we continue. The result, the ultimate result in each case for a particular number will be same. Here the result is 3. What is 3? 3 is nothing but 1 plus 2 is 3. In this case, the result is 6. What is 6? 1 plus 2 plus 3 is 6. Then again, 1, 2, 3, 4. The ultimate digit sum is 1. What are these numbers? So if you are aware of or not, that if you add all the digits of a number and then add it again and again till you receive a single digit number, that number is nothing but the remainder when a number is divided by 9. Interesting, right? For example, 23. What is the remainder when 23 is divided by 9? Remainder is 5. What is 2 plus 3? It's 5. 101. What is the sum of the digits? 1 plus 0 plus 1. It's 2. What is the remainder when 101 is divided by 9? Again, the remainder is 2. So it does not matter where do we start putting the partition in this number, and then again the next partition or any order of the partition, it does not matter. What matters is what is the remainder when n is divided by 9. So what is n? If I add all of these numbers, right? So that is nothing but, we can say if I add these numbers, 1 plus 2 plus 3 till 100, this gives us 100 into 101 by 2, which is equal to 50. That is equal to 5050. So what is the remainder here? When 50, again we can also add the digits of 5050, still it will have the same result. So 5050 when divided by 9 will be equal to 5 plus 0 plus 5 plus 0, which is 10. Again, 1 plus 0 is 1. This is going to be our answer, that the single digit NM will be